In this video, I'm going to teach you how to solve the question on my screen. The question says, determine whether the following characteristic equations represent a stable or unstable system. State the number of roots in the right half S-plane. Give full reason for your conclusion. For the first one, we have that the first equation is s to power 5 plus 4s to power 4 plus 8s to power 3 plus 8s to power 2 plus 7s plus 4 is equal to 0. We have the second one to be s to power 4 plus 3s cubed plus 6s squared plus 12s plus 8 equal to 0, and the last one to be s to power 5 plus s squared, plus s to power 4 plus 3s cubed plus 15s plus 3x squared plus 15s plus 10 is equal to 0. So now starting from the first one, Routh-Hurwitz criterion is a method that is used to check the stability of a system using equations given. So if the equations have large powers, and which means they have a lot of roots, use Routh-Hurwitz criterion as one of the methods of finding the stability of the system. So solution: using Routh-Hurwitz criterion, the first thing to do for equation 1, the first thing to check for is if all the coefficients of s are present and if they are positive. So we can see that all the coefficients of s are present. We have s to power 5 1, s to power 4 4, s to power 3 8, s squared 8, s 7, and s to power 0 4. So they are all present. Then the next test will be, after drawing our Routh array, so just follow me. There is a pattern to draw the Routh array and actually test for the second condition. So the first thing, take the first coefficient to get the Routh array. Start from the first power and keep going down. 3s squared s and s 0. Now we start from here. Just follow me. This is a pattern. Now we take the coefficient of s to power 5, which is 1, and put it here. And then you skip coefficient of s to power 4, take the coefficient of s to power 3, which is 8, and you put it here too. And then skip that for s to power 2, take the one for s, which is 7. And then 0. But we are not going to take that one. Then for s to power 4, do the same thing. Take the coefficient of x to power 4, which is 4, and skip the coefficient of s to power 3. Take the coefficient of s to power 2, which is 8, and the coefficient of s to power 0, which is, what was it again? Which is 4. So now, in order to get the one for s to power 3, s to power 2, s1, s0, for this first column, to be this times this minus this times this divided by this. So this should be 4 times 8. 4 times 8 minus 8 times 1 divided by 4. You have 6. And then for this second column, it will be this 4 times 7 minus 1 times 4 divided by 4. So this will be 4 times 7 minus 1 times 4 divided by 4. This will give you 6. Then for the third column, you have 0, because there is nothing on this other side, the right hand side again. So that will be automatically 0. Then you do the same thing for s squared. It will be 6 times 8 minus 4 times 6 divided by 6. So 6 times 8 minus 4 times 6 divided by 6. You have 4 as your output. And for this one, to be 6 times 4 minus 4 times 0. 6 times 4 minus 4 times 0. Divided by 6. This will give you 4. And this last column is also 0. Now for this, for s to power 2, we have not even done s1. Let me see if I can. Let me move it here. S0. So now for s to power 1, you have that 4 times 6 minus 6 times 4 all over 4. And that will give you 0. 6 times 4 or 4 times 6 minus 6 times 4 over 4. This is equal to 0. This side too is 0 and this is also 0. But we cannot end it. We cannot end it like this. This array is not complete as long as there is no s to power 0. This array is not complete, and we are having 0 at s to power 1, which means the array is ending prematurely. We need to actually continue till s to power 0, and in order to do that, we have to form an auxiliary equation that will help us to get a value for s1. So form that auxiliary equation from x squared. So we have that from the row x squared, we have auxiliary equation is equal to 4s squared plus 4. From here, normally we know that this will be 4s squared, then you skip one of the coefficients and then you go for the next. So this is it. Now to get the value that we are going to substitute in place of this 0, we are going to differentiate this. So differentiating, will have, with respect to s, we'll have 8s. So after having this is so after having 8s, we can now substitute it into this. So this will be s to power 1, 8, and then 0. Then this will be s to power 0. To get the last value, just as we did before, it will be 8 times 4 from here. 8 times 4 minus 4 times 0. All divided by 8. So this will give you 4. Well, let me just write it. 8 times 4 minus 4 times 0 all over 8. This will give you 4 and 0. And this will also be 0. This will also be 0. So we have completed the array. Now the second condition, we can now check from the array. Second condition states that there must be no sign change, or there must be no negative sign in the first column of the Routh array. So since there is no negative sign, that means the system is stable. Since there is no sign change in the first column of the Routh array, the system is stable. So these are the only two conditions we look out for. We check if all the coefficients of S are present and positive, and check if after forming the array, if the first column there is any negative sign. So this also implies, because from the question it says state the number of roots in the right half S plane. There is no root. There is no root in the right half S plane. This implies that for a system to be stable, there must be no root in the right half S plane. This implies that all roots are in the left half S plane. Now moving to question 2. Moving to question 2. We have S4 plus 3s cubed plus 6s squared plus 12s plus 8 is equal to 0. The routes RA for the system is we have this. Then we have s to power 4, s to power 3. Just like I did last time, just follow me. S squared, s to power 1, s to power 0. So now, just like I did for S4, take the coefficient, skip one, take the next one, skip the other one, and take the next one, 8. Then for this, do the same, 12 and 0. So now, I want to be very fast in this one. I don't want this video to be too long. So this will be 3 times 6 minus 12 times 1, just like I did in the last question. 3 times 6 minus 12 times 1 all divided by 3. You have 2 as your answer. 2. And then for this one, it will be 8. This is 0. This will be 0. This will be 0. And this will be 0. So I said something. If we have a case like this, we are going to use the equation from s squared to actually get a value that we are going to substitute in place of 0 in this s to power 1. So the auxiliary equation A of s is equal to, we have from here 2s squared plus 8. The as over the s is equal to 4s. Now we are going to substitute that value in place of 0, which will be 4 and then 0, then 0. And this, the last one, just following the same pattern, you have 8, 0, and 0. So we can see from the first condition is fulfilled, second condition is also fulfilled. This shows that the system is stable. So this shows that the system is stable since there is no sign change, or there is no negative sign in the first column of the Routh array, and all the coefficients of S are present and positive. And this also implies that all the roots are in the left half S plane also.